Hello students, in this video we will be solving problems under exercise 7.1 and we will be solving problem 2, 3 and 4. We have solved problem 1 or question 1 from exercise 7.1 in the previous video. So keep watching and we will solve the 3 questions in this video. Our first question is find the distance between the points 0, 0 and 36, 15. So let us apply the distance formula between the two. Before we do that, let us assume those points. So we will say solution, let A 0, 0 and B 36, 15 be the points, be the given points. Next, we apply the distance formula. AB equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now what is x2 over here? If we want, we can write it over here. x1 is 0, y1 is also 0 and x2 is 36 whereas y2 is 15. So substituting the values over here in this distance formula, x2 is 36, x1 is 0, whole thing raised to square, plus y2 is 15 and y1 is 0, whole thing raised to square. So 36 minus 0 gives us 36 whole square and 15 minus 0 gives us 15 whole square. Now 36 whole square is 1296 and 15 whole square gives us 225. When we add 1296 to 225, we get 1521. So if we remove the factors of 1521, you should be able to get 3 5s are 15, 0, 3 7s are 21. Again 3 1s are 3, carry 2, 3 6s are 18, 2 7, that is 3 9s are 20. Again we can go with 3 or not 3, this should be, let me see, 13, 13 1s are 13, carry 3, 3 39, 13 3s are 39, 13 1s are 13. So that means you have 13 over here and you have 3 over here. 13 into 3, that gives us 39. That means square root of 1521 is 39 and that would be 39 units. That is the distance between the points A and B. The next question 3 says determine if points 1, 5, 2, 3 and minus 2, minus 11 are collinear. The word collinear means if there are 3 points, they should be in line with each other. They fall on a particular line. Okay. And to prove that these 3 points are collinear, what we'll have to do is the distance between the sum of the distance between any 2 points. Like for example, if we take this as A, B and C, these the 3 points, and if we take AB plus BC, now that should be equal to AC. That means the sum of those two, the distance between the sum of the 2 points should be equal to the distance between the third. Okay. In other words, we call it, for 3 points to be collinear, we need to prove that the sum of distances between 2 pair of points, like for example this one and this one, is equal to the third pair of points. So it it is enough to prove either this, or we can take as AB plus AC equal to BC, or BC plus AC equal to AB. You are getting it? First of all, we need to find out AB, BC and AC, and then by adding in either of these three, the combination of these three, we have to see if any of one of the combination gives us the third pair, the distance between the third pair of points. Only then we can say that this is collinear. But if all three are not equal, then we can say that these points are not collinear. I hope you're getting it. Collinear points are those which lie on a line. Okay, there are many points, infinitely many points on a particular line, and those points which lie on this line are said to be collinear, means they follow one after another or they belong to the same line. The way to prove it in coordinate geometry using distance formula is to find out pairs between the distance of the pairs between them. So we create pairs. Now we have point A, point B, point C, which we will assume as we solve this video, solve this problem in this video. We find out first the distances between them. We find out distances AB, AC or BC. Then what we do is we add them up after finding to see, and we add just two pairs to find if we can get a third pair, like we add AB plus BC, and the total, if it comes equal to AC, then we can easily say that these 3 points are collinear. Similarly, we can find out, so any one if we get is more than enough. Okay, but if we do not if we find that all 3 combinations are not equal to the third pair, then we can say that these points are not collinear. So let us first solve this to understand how to solve such problems. So we'll begin with the fact that we need to assume basically the 3 points first, like we always do. So solve, let A 1, 5, B 2, 3 and C -2, -11 be the given points. Okay. Now we need to find out AB, BC and CA or AC, whatever. So AB, we'll find out that first. So AB is given by the distance. Oh, before that we'll write down what is x1, x2, x3. Okay, so x1 is equal to, so this will be x1 1, okay, and y1 will be 5. Then x2, I'll put a semicolon over here, x2 will be equal to 2 and y2 will be equal to 3. Another semicolon, x3 will be equal to -2 and y3 will be equal to -11. Now let's use the distance formula. So now let's find out the distance AB, and the formula is x2 minus x1 whole square plus y2 minus y1 whole square. x2 is 2 minus x1 is 1 whole square plus y2 is 3 and y1 is 5 minus 5 whole square. That will give us 2 minus 1 gives us 1 whole square plus 3 minus 5 gives us -2 whole square equal to square root of 1 whole square gives us 1 minus 2 whole square gives us +4. That should give us square root of 5. Now let us find BC. To find BC, the formula changes slightly because this BC, the coordinates of B is x2, y2 and but the coordinates of C is x3, y3. So accordingly the formula changes to x3 minus x2 whole square plus y3 minus y2 whole square. So let us see what we get. x3 is -2 and x2 is 2, so that will be minus 2 again, plus y3 is minus 11 minus y2 is positive 3, so that will be minus 3 whole square. Now moving further, minus 2 gives us minus 4 whole square, and minus 11 minus 3 gives us minus 14 whole square, equal to now minus 4 whole square gives us 16, and since this is minus 14, the square of it will be positive, so that will be positive 196, because 14 square is 196. This gives us square root of 212. If we go to factorize 212, let's see what we get. 2 1s are 2, 0, 2 6s are 12, 2 5s are 10, 2 3s are 6, and we'll have 53 1s are 53. So this can be written as 2 square root of 53, because only one pair you get over here, 2. Next we go to CA. Okay. So CA would be, this is coordinates of C is y3 comma x3 comma y3, and coordinates of A are x1 comma y1. So it would be x3, or not x3, it would be x1, because it is CA, right? So x1 minus x3 whole square plus y1 minus y3 whole square. What is x1? It's 1, minus x3. x3 is minus 2, so that would be minus 2 in the brackets, whole square, plus y1 is 5, minus what is y3? Minus 11 in the brackets, square. Sorry. Now 1 minus of minus and minus gives us positive over here. So 1 plus 2 gives us positive 3 whole square, plus minus and minus gives us positive, that means 5 plus 11 gives us positive 16 whole square. Positive 3 whole square gives us 9, plus 16 whole square will give us 256. When we add 256 to 9, it gives us square root of 265. Okay. Now, can we get factors of 265? Let us see. 265, 5 5s are 25, carry 1, 5 3s are 15, 53, 1. So no, there are no factors. So it would be just 2 root 65. I mean, sorry, square root of 265. So clearly, if you have a look, whatever combinations we may take, we are not going to get this collinear, but we need to show it or write it down, put it down on the paper. So it would be, we can say AB plus BC is not equal to CA, or AB plus CA is not equal to BC, or BC plus CA is not equal to AB. So you can say this implies that the given points A, B and C are non-collinear. Okay. So this is how we solve problems when asked to prove whether the given points are collinear or not. Coming to the fourth problem, we need to check whether A 5, minus 2, B 6, 4 and C 7, minus 2 are the vertices of an isosceles triangle. What's an isosceles triangle? An isosceles triangle would be a triangle where any two sides are equal out of 3, any two sides should be equal. So if we take A, B and C, either AB should be equal to AC, or AB should be equal to BC, or BC should be equal to AC. Means any two sides of a triangle should be equal to call that triangle as an isosceles triangle. So we need to find the distance or the length AB, BC and CA, and then see if any of the two lengths of this particular triangle are equal. If they are, then we can say this is an isosceles triangle. Okay, so let's begin first by finding out the distances between the three pair of points. First we'll just write down what is x1, x2, x3 and y1, y2 and y3. That will help us to use in the distance formula. Okay, so let's begin with x1 equals, so we can say let a x1 comma y1 correspond with 5 comma minus 2, then b x2 comma y2 correspond with 6 comma 4, and c x3 comma y3 correspond with 7 comma minus 2. Okay. So now we put down what is x1, x2, x3, y1, y2 and y3. So we'll put over here AB. Let's find out AB, then we'll find out what is BC, and finally we'll find out what is CA. Beginning with AB, we'll use the distance formula. So this is x1, y1, so, and this is x2, y2. So x2 minus x1 whole square plus y2 minus y1 whole square, and this would be, BC would be x3 minus x2 whole square plus y3 minus y2 whole square. Similarly CA would be x1 minus x3 whole square plus y1 minus y3 whole square. Okay. Now let us begin substituting one by one. So let's find out AB first, then we'll go to BC and then we'll go to CA. AB x2 is 6. 6 minus x1 is 5, minus 5 whole square plus what is y2? y2 is 4 minus y1 is minus 2. Whole thing is raised to square. That would be 6 minus 5 gives us 1 whole square plus minus and minus will give us plus. So 4 plus 2 gives us 6 whole square equal to 1 whole square gives us 1. 36 whole square gives us, 6 whole square gives us 36. That gives us root 37. Next, x3 minus x2. x3 is 7 minus x2, which is 6 whole square plus y3 is minus 2 and y2 is 4. So that would be minus 4 whole square. See what we get. 7 minus 6 gives us 1 whole square plus minus 2 and minus 4 gives us minus 6 whole square equal to 1 whole square gives us 1, minus 6 whole square gives us 36 positive. That gives us root of 37. And we have finally, clearly you can see these two sides are already equal. We don't need to do the third one, but since we put it down for your sake, let us just find out if the third side is not, because if the third side is also equal, then this becomes a equilateral triangle and not an isosceles triangle. Again, we have been asked to find out whether this is an isosceles triangle. So if we get all three sides equal, then we have to say that this is not an isosceles triangle again, though we have got two sides equal, but we have got more than two sides. When all three sides of a triangle are equal, then it becomes an equilateral triangle. So let's just find x1 minus x3. x1 is what? 5 minus x3 is 7 whole square plus y1 is minus 2 and y3 is minus 2. So minus of minus 2 whole square. Next, 5 minus 2 gives us minus 2 whole square, plus minus and minus will give a positive 2. So minus 2 plus 2 gives us 0 whole square, and that should give us minus 2 whole square gives us 4. 4 plus 0, that gives us 4. So square root of 4 is the square root of 4 is 2. So clearly the third side is not equal to the, but that is more than enough for us. So we can say AB is equal to BC. Therefore, points A, B and C are vertices of an isosceles triangle. Okay. So any 2 points we need to show a pair of any 2 points, we need to show that they are equal to each other. Okay. So we need to show either AB is equal to BC, or AB is equal to CA, or BC is equal to CA. Now we've got AB is equal to BC. That is more than enough to show that this pair of points which have points which have been given are actually the vertices of an isosceles triangle. So in other words, what it means from the whole thing. So if we draw a triangle, let's just assume this is a triangle, and this triangle is on a graph, on a graph paper. What it's trying to say is this is a point over here, the point over here, and point over here. Okay. So these points, when they are joined together, they form a triangle. They would just be actually like this. If you draw a graph, okay, draw the graph here. I'll just erase this part to show you all what exactly it means in terms of a Cartesian plane. You have your y-axis, you have your x-axis over here, and these 3 points actually are something like this. One point you'll find here, another point you will probably find here, and the third point probably you'll find here. Okay. Now these are just 3 points at random which are on this Cartesian plane. I'm just taking this example to show you all how exactly it comes on a graph paper. If we join these points, then they will form a triangle like this. Okay. And any 2 points, maybe these 2 points are equal. I mean, these 2 lines that are formed by joining these points are equal. As part of the triangle, that triangle then becomes as an isosceles triangle. So if we had to take this one A, and this is B, and this is C, what we have actually shown in our working over here is that AB is equal to BC. So maybe this we can take as B, and this as A, and this is C. Yeah. So then AB becomes equal to BC. That is how it comes when you draw a graph. So by working, we can find out whether the points that have come plotted on this graph paper or this Cartesian plane, do they actually form an isosceles triangle when the points are joined or not. Okay. So this is how we solve such problems. So if you like watching this video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive updates whenever a new video is posted. Thanks for watching. See you in the next video.